Now we see the second use of a scalar triple product, and that is in finding out the volume of a tetrahedron. So as shown here in the figure, a tetrahedron is a solid figure with 4 faces. That's why it's called as tetrahedron. And you can see that there are 4 vertices. We call them as O, A, B and C. Now in case of a tetrahedron also, let us consider the 3 coterminous edges as A bar, B bar and C bar. So as you can see in the figure, the side OA we call as vector A bar, side OB as B bar and side OC as C bar. And we have to derive the formula for volume of a tetrahedron. Now we will be using the similar method that we use to calculate the volume of a parallelepiped. Alright. The basic formula to calculate the volume of a tetrahedron is, it is 1/3 into the base area into height. Now if you see in the figure, the base here stands for the triangular base. So therefore it will be the area of this particular triangle, that is OAB. Right. So therefore we get base area. We have seen earlier that the area of a triangle is nothing but 1/2 into the cross product of the adjacent sides of a triangle, that is A bar and B bar. And now in case of height, we follow the same technique, that is, let us drop a perpendicular from that upper vertex on the lower plane. That becomes our height h. So if we join that particular foot of perpendicular with O, we will get a right angle. Okay, so that becomes a right angle triangle. Let us call the foot as M. So triangle OCM is a right angle triangle at M. Now if you consider a vertical direction, clearly the vector A bar cross B bar will lie in this particular direction. And if the angle between A bar cross B bar and C bar is taken to be theta, then same is the angle between the side OC and the vertical height. So we write the height h. Now we see that height h is nothing but mod c into cos theta. And cos theta can be calculated as the angle between C bar and A bar cross B bar. So therefore that we can write as C bar dot A bar cross B bar divided by mod C into mod of A bar cross B bar. Right? So therefore the C bar and C bar mod will get cancelled, leaving H as equal to C bar dot A bar cross B bar divided by mod of A bar cross B bar. So therefore on substituting we get 1/6 into mod of A bar cross B bar into C bar dot A bar cross B bar divided by mod of A bar cross B bar. So therefore the mod of A bar cross B bar gets cancelled, and finally we get 1/6 C bar dot A bar cross B bar. And we observe that this is nothing but the scalar triple product of C, A and B. And if we do a cyclic change of vectors, we can also write it as the box product of A bar, B bar and C bar, just to look at as a standard form. So therefore that's the formula for volume of the tetrahedron. Now if the value of the box product turns out to be a negative, we take its absolute value because it's a volume. Now let's solve one example based on this. Find the volume of the tetrahedron formed by 4 points A, B, C and D. So let us arbitrarily draw the tetrahedron. Let us take A point, then B, C and D. So now here we have to be very careful, because the vector, position vector of A bar, which we normally show as A bar in lowercase. Now that is not the same A bar as we use in the box product to calculate the volume of the tetrahedron. Okay. In case of volume of the tetrahedron formula, A bar stands for one of the three vectors, the three sides which are having a common point. So let us call that point as A. And now here, for the sake of convenience, let us consider A bar as the vector which represents side AB. Okay, so that has to be clearly understood. Now let us consider B bar as the vector that represents the side AC, and let C bar be the vector that represents side AD. So basically we have to calculate those vectors. Right? So therefore we have AB bar, which as per our convention only in this problem is what we are denoting as A bar. So what we'll be doing is we'll be subtracting the respective coordinates. Right? So therefore we get 4i minus 4j minus 2k. Similarly, let us calculate the second vector, that is AC bar. So we will do C minus A. Right. Here, okay, we call that vector as V bar, and that gives us 3i minus j plus, there is no k, so still write it as 0k. And lastly, the third coterminous side is AD bar, that is we are doing D minus A. Now this side we are calling as C bar, and here I is getting cancelled, minus 4j plus k. Now the volume is given by 1/6 the box product of A bar, B bar, C bar, where A bar, B bar, C bar are the coterminous sides which we have already calculated. So that gives us the determinant 4 minus 4 2, 3 minus 1 0, 0 minus 4 1. We'll simplify this further. That is equal to 1/6 4 into bracket minus 1 plus 4 into bracket 3 minus 2 into bracket minus 12, which is equal to 1/6 minus 4 plus 12 plus 24, which turns out to be 1/6 into 32. So cancelling 2, we have 16/3 cubic units. So that's the volume of the given tetrahedron.